Okay, so pitch and frequency are not the same thing. Frequency is just how frequent something happens. It's the number of cycles per unit time of an oscillation. And it's a physical property of sound that we can objectively measure. But pitch is different. It's how we perceive frequency, and it's what we use to divide a keyboard. We measure it in semitones, and then we also measure the small increments of it in cents. And one of the ways the pitch and frequency differ is when it comes to complex sounds. So, like, this is an A, the musical note A, but this is a frequency of 440 hertz. And even though the A is not the same thing as that, it's got more frequency content to it, we hear them as being the same pitch. This is usually just caused by a sound having a louder fundamental frequency, like that's the 440 hertz peak of an A, but this note is also an A, even though it's missing that fundamental frequency. This is called a missing fundamental. Anyway, another thing you have to think about when it comes to pitch and frequency is that our perception of frequency is logarithmic. To see what I mean, just have a look at this keyboard. Between this C and this C, there are 12 semitones. But between this C and this C, there are also 12 semitones. When you go up by the same interval, you add pitch. So we could say that an octave has a pitch of 12 semitones. So what about frequency? Well, there's no amount of hertz that you can add to a frequency that always makes it go up to an octave. The idea of an octave frequency doesn't really make any sense. What actually happens is when frequency goes up an octave, it doubles. So, when you multiply frequency, you add pitch. This is really important when you're dealing with pitch shifters and frequency shifters. So a pitch shifter is literally just going to transpose it because it's accounting for our perception of frequency. But if you apply a frequency shifter, well, that's going to stretch it linearly. But because our perception is logarithmic, that's what it sounds like. This rabbit hole goes very deep. There's also some evidence that a pitch is not affected just by frequency, but also by amplitude, which means that when a sound gets louder, it increases in pitch without increasing in frequency. Yeah, that's a thing. There's a lot to talk about. I can't fit it in this video. I might have to make a YouTube long